Hello everyone. This is a basic tutorial on how to easily create animations like the one you're seeing on screen, where some electronic components gradually fall onto a rotating printed circuit board. Specifically, I will cover topics such as parenting and shifting keyframes in the timeline, making this tutorial suitable for beginners in Blender. For this tutorial, I am using Blender version 4.3, but the concepts and tools used have been valid for several versions of the software and will likely remain relevant in the future. Unlike most of my video tutorials, the PDF version of this tutorial is not currently available for download. However, you can find a link in the description to a page containing PDF versions of many of my other video tutorials. In any case, this is a great time to subscribe to the channel and turn on notifications. In the animation I want to create, the electronic components fall in groups onto the rotating printed circuit board. To create this animation in a way that allows easy modifications later, such as changing the rotation of the board or adjusting the keyframes of the components, the first step is to parent the components to the printed circuit board. To establish this parent relationship, I select all the components in the printed circuit board using multiple selection, making sure to select the board last by holding Shift and left-clicking. This ensures that the board is the active object in the selection. Once this is done, I press Ctrl P and choose Set Parent to Object. We can verify the operation by checking the hierarchy in the outliner or by selecting only the circuit and moving it. This way, when I transform the circuit to record its animation, the components will follow it. At this point, I need to select only the components and record the keyframe at the moment when I want all of them to be resting on the circuit. I will be able to easily modify this keyframe, just like any other later on. Keyframes can be inserted by pressing I or by selecting Insert Keyframe from the right-click menu. It's important to make sure not to insert this keyframe for the printed circuit board, but only for the components. Just as an example, I'm inserting this keyframe at frame 190 in the timeline, so that the animation ends with a couple of seconds where all the components remain in place. Now I move to, for instance, frame 40 in the timeline. I drag all the components very high up and insert a new keyframe for them. At this point, until frame 40, all the components remain far from the circuit and do not move. Then they all fall onto the circuit by frame 190. Now I can select the objects representing the different types of components, one by one in the outliner, and then move the diamonds representing the first and last keyframe in the timeline, adjusting when their fall begins and ends. For example, I want the resistors to be the first to fall onto the board, starting at frame 60. To achieve this, I leave the first keyframe as it is but move the last keyframe from frame 190 to frame 60. To move this diamond, I click and drag it with a mouse. Alternatively, I can select it and move it using the G key and mouse movement. Now I select the capacitors, move the first keyframe to frame 60, and then move the last keyframe to frame 90. For the integrated circuits, I set the range from frame 90 to frame 120. Finally, I set the range from frame 120 to frame 150 for the connectors. I click the play button in the timeline to preview the animation so far. I can fine-tune the timing of this animation by adjusting the keyframes of the various components, but I can also move on to animating the printed circuit board and leave these refinements for later. To animate the board, I first select it, go to the first frame of the timeline, and insert a keyframe for this object. Then I go to the last keyframe in the timeline, transform the board using rotations or movements, and insert a keyframe for the object. For example, I'm setting a 720-degree rotation around the z-axis and 30 degrees around the x-axis so that the board appears slightly tilted at the end of the animation. Now, by playing the animation preview, I can evaluate the final result and adjust the timing by shifting keyframes in the timeline. In fact, 10 seconds is too long for this animation, so I reduced the end frame value from 250 to 125, cutting the animation duration in half. To easily shift all keyframes at once and fit them within the new duration, I first select all objects in the 3D viewport by pressing a while the mouse cursor is over it. Then, I move to the first frame of the animation. Now, with the mouse cursor over the timeline editor, I select all keyframes by pressing A. Finally, I press S to scale the selection. A quick correction for my future self. After recording the video, I realized that by scaling the keyframe selection to fit the last keyframe within frame 125 of the new animation, I didn't leave any time with the components resting on the board. To fix this, I scale the selection again while positioned at the first frame of the timeline, ensuring the keyframes are resized relative to that moment. Scaling the keyframe selection in the timeline happens relative to the current frame, so in my case, it will scale based on the first frame of the animation. Of course, I can also manually select and shift the keyframes of the different components little by little to further refine the timing. I can also scale multiple selections, but I need to keep in mind that these adjustments will be relative to the current frame, so I will likely need to move it each time. As you may have noticed, the rotation of the printed circuit board does not occur at a constant speed. It accelerates at the beginning and decelerates at the end. To achieve a constant speed rotation, I need to change the keyframe interpolation type from Bezier to linear. To do this, I select the printed circuit board in the 3D viewport, then select both of its keyframes in the timeline. I right-click in the timeline, go to interpolation mode, and choose linear. This way, the board's rotation will have a constant speed. Now, I just need to review the animation and make any necessary timing adjustments until I achieve the final result. Alright, that's it for this tutorial. I hope you found it useful. See you soon.